Okay, we are moving into summarizing data part 2. Okay, in part 1, we looked at the ways we could graphically and numerically summarize one single numerical variable. Okay, as we know, we often investigate other relationships. This slideshow is going to look at some of the graphics and numerical summaries we can create with R that will do the same analysis for different types of variables or different combinations of variables. We're going to start out with a single categorical variable. Okay. What would we want to do? We often use xtabs simply to count the number of responses in each category. For example, if we were looking at the UC Davis 1 dataset and we wanted to know how many people responded to each section of seating, using xtabs would give us that count in number. Okay, so if you were to count all of the responses at UC Davis, we would have 37 responses that say they prefer to sit in the back, 41 in the front, and 93 in the middle. Okay, again, this is a command that you should practice typing into RStudio. If you look at the format, we have the command, which is xtabs, twiddle, and then the title of the variable. It has to match how it is coded in the actual data set. So we see it here, seat is capitalized. So I know if I were to open R and I were to look at the UC Davis 1 data set, the heading above the category that represents which seat choice they chose, seat would be capitalized. Okay? So if I were to come over here and click on UC Davis, I do see seat is capitalized. Okay? Moving forward, most of the time we would rather see percentages, okay, than count. That's a little bit more telling. It's hard to know if you're looking at a count, if I say, 10 people chose this, if that's like a lot of the group or if it's little of the group. So percentages sometimes can be a little more insightful. It just depends on what our focus of the study is. So if we add sort of a double count here, this you see the xtabs command is still present. If we put the rowperk command around it, it will count that and then it will turn those values into percentages. So instead of having an individual count of how many people chose back, how many people chose front, how many people chose middle, we know the percentage of the total survey group who selected each category. Okay, so there's another way to do it. I honestly think it's a more complicated way to do it, but the steps that you see here would create sort of like a sub data set. It would create a list. And that's what this part is doing. It's naming this new list seat UC Davis. And this command, of course, to RStudio means store. So it would be doing the count of each person in each number of people in each seat selection choice. And then it would save that as sort of its own list. And then we would still have to use rowperk, but instead of having the xtabs command inside of it, you would just use the name of the list. Again, I think this is probably the more complicated way. Just double layering the commands is a one-stop shop to getting there. Okay. So what's going on there? Okay, that's just what we described. We're creating a list and then we're converting that list to percentages. Okay. So what's another way we can look at this other than just counting and finding percentages? Okay, that's sort of our numerical summary. But in terms of displaying that as a graphic, remember we always like graphs because they make patterns very obvious and very visual to the reader. So bar charts is a good way to do that. The command we use for bar charts in RStudio is bar chart capital GC. Okay. We also are going to use the twiddle, the variable, the categorical variable that I'm trying to create the chart of, and the data set. Now, just like other commands, anytime I create a graphic, I can add this main tag or the XLab tag. I can add any of those and put a title on what it is that I'm creating. So this command is going to make a bar chart of seat preferences using data from UC Davis 1, and it's going to title that seat preference at UC Davis. So it would probably be beneficial for you to pause the video every time you see a new R command and practice typing it in. If you do not do that, when it comes time for you to actually use these commands, sometimes things don't work out right. Sometimes you type the wrong thing. Okay? If you do not practice it in the video so you can ask questions in class, then that's going to create a situation where you feel very frustrated. So please pause and practice. Hopefully, once you've tried it, this is the result that you should see in RStudio. We have a title seat preference at UC Davis, and we have the number of results of each person's choice in this category. Okay. So we also can make those using percentages. The previous one just did it using counts. If we were to throw in the qualifier that said type, notice we equal percent here, then that's going to create a bar chart for us that's based not in count, but in percentage of total responses. So that we've done a single numerical, that was in part 1. We've done a single categorical so far in part 2. Now we're moving on to what would we use if we were comparing, our question was comparing 2 categorical variables. Okay, so this is an example of a research question that would do that. Is seat preference at UC Davis associated with gender? Both seat preference, front, middle, back, and gender, male, female, are categorical. So if we're going to compare them, we can't use the same strategies we would with numerical variables. Okay. We are, first of all, we have to think about which of these might be explanatory in the relationship. Sometimes, like we said, that relationship is not always very obvious. But here, obviously, what seat we choose is never going to determine what gender we are. That's been determined significantly a long time ago, either in our chemistry or in our birth or in our thought processes. So seats and gender or sex, obviously our gender is going to be the explanatory variable in this relationship. We cannot change our gender just because we sat at a different seat. That's not a reasonable explanation. Okay. So if that's the case, we can use numerical methods to calculate these. We can use X tabs, okay? If this is, again, creating that list, just like we saw previously on that slide, we're creating a count of those in each category. If we just ignored the seat by gender and the arrow and looked at just the X tabs command, if you were to run just this on RStudio, okay, we have twiddle, explanatory plus response. Notice that's backwards from the XY plot. Okay, in XY plot, we had response and then explanatory. So here, explanatory plus response, and again, where the data comes from. And we see that information here. We're not going to try to store it in a list, although you certainly could. But if we then ran row perk of this XTabs command, we would get the percentages by gender. Okay, and notice it breaks it down. 100% now refers to the percentage of each gender. So about 16% of all of the females, about 28% of all of the females, about 56% of all of the females. Okay, it's a very similar type into R. The only difference in typing from a single categorical variable here is that we're adding the plus, and we have to put the explanatory first. Okay. So we also can make bar charts, okay, just like we did of a single categorical variable. When we're going to compare two, making a bar chart sometimes is an excellent way to see the pattern that may not even be visible sometimes, or at least obviously visible to us in the numeric breakdown. Okay, so it's the same way we formatted the bar chart command when we had a single categorical variable. The only difference is we've added the second and we've listed the explanatory first. We've given it a title. And here we're adding the type percent is going to create a bar chart represented in percents. Okay, so when we look at this, what do we see? Okay, often we ask students in statistics to describe what they see, and students start talking about why they see what they see. In statistics, when we're analyzing data, we have not yet gotten to the point to where we can make hypotheses about why what we see. All we can describe is exactly what's in front of us. We're not trying to say why, we're not trying to say when, we're just trying to say, this is what I see, okay? So if we were looking at this data, what would we see, okay? Obviously, both males and females, when I look at both groups, we see a preference for the middle in females, and we also see a preference for the middle in males. So they have that in common, okay? What do we see that's different? We see that if we exclude the middle choice, that females will prefer the front to the back, whereas males would prefer the back to the front. Okay. So we also can make a bar chart a different way. The author in our textbook calls it a stacked bar. This sort of lets you see more clearly how percentages within each gender compare. The only thing we change is to add this flat equals true. Now, in computer language, that just means whenever you have an equals true, you want it to perform some sort of adjustment or some sort of specification for you. So this flat equals true is going to change the type of bar. We're getting a flat bar chart essentially. Okay, so here's what we can see. It sort of starts them both off at 0, and then we compare back, front, and middle. Be very careful about how you read your bar charts because RStudio often will take the variables and arrange them in alphabetical order. Most of us are used to thinking front, middle, back, or back, middle, front, but that's not how it's displayed here. Back, front, middle, and that's just because of alphabetical order. It is a little bit easier to make comparisons here. Okay, we see both have obviously a higher preference for the middle, just like we said, but we do have more males that are selecting the back over the front than females. Okay. So now we've done one numerical, one categorical, two categorical. Now we're going to look at what we would do if we were asking a question about one of each, how they compare, one categorical, one numerical. An example of that would be who has higher iron levels in their bloodstream, men or women, okay? Iron levels, of course, is going to be a numeric response, whereas gender is going to be a categorical variable, okay? So we're wanting to compare the iron level of women to the iron level of men. Since we're analyzing something numerical, we do want to see density plots, favstats, and box and whiskers. Whenever numbers are in play, we want to see those numerical analysis tools that we saw in previous slideshows, okay? So what's going to be different? We are going to have to just do this command so that it creates one for each categorical group we're trying to view. And we're still using the same density plot command. Okay, it's still density plot. We still have twiddle and the variable. The difference is here we have two variables. We don't just have iron level, we have iron level and gender. Now this straight line, I have a lot of people ask, where is that on the keyboard? It is on the same key as the backwards slash, and on my keyboard, it's directly above enter, okay? So I'm gonna use response, explanatory, data equals wherever it's coming from. This particular one is coming from NHANES 18. Okay. Again, main would give me a title. XLab would label the x-axis. Okay. And layout just tells it in what order to put these first gender, second gender. Okay. We could leave out the main and the XLab on this if we wanted to. Okay. If we weren't turning it in. Okay. So here we go. Here's our title. I've got a male chart and I have a female density plot. Okay, so we have a unique set of numerical responses for each gender, and that's kind of what we expect to happen. In order to compare them to each other, we need to see that analysis of both. Okay. Same thing I can do with favstats. Instead of doing it with a single variable, I can do it with two. Okay, we have female and male here. Again, I'm pretty sure it's following that alphabetical order analysis, but it gives us sort of a double layer of information. Okay. We can also make a box plot, or I'm sorry, not a box and whisker plot here, which is a numerical analysis tool, again, using both variables, okay, and we're going in the same format of response explanatory. And here we labeled both the X and Y axis so that would be easier to read. So here's our gender, and here's their iron level, and we sort of have inverted these box and whisker plots. So we see quite a bit of outliers happening in both of these. Right? Now, what would we see? How would you describe the distribution of iron levels for each group? And how do the distributions compare? What's the same and what's different? If I were trying to describe these, again, I'm not going to say why, I'm not going to say how. All I'm going to say is that both distributions seem to be unimodal and right skewed of iron levels, okay? Whereas males are tending to peak just a little bit ahead of females. Okay, we have that mode for males occurring just a little bit higher than females. If you view the box and whiskers, you'll also see that reflected here. You see the median value for males just a little bit higher than the median value for females. If you know anything about biology, you know that tends to be true. Men tend to have higher levels, iron levels, than females do. And it is related to gender and the functionings of our body. But there are a significant number of outliers in both genders. Okay? If I'm just describing what I see, I'm not going to approximate why. I'm only going to reflect the patterns that I view, either in the numbers I'm looking at or the graphics that I see. Okay? So there are some questions for you to answer. Basically, each question asks you to use some type of command for each variable, a single numeric, a single categorical, two categoricals, one of each. Okay, why did we not do two numericals? You already did that. Okay, that's what the scatter plot did for us in the very first slideshow that we looked at. It compared two numerics. Please make sure that you don't just type the commands into your response for this assignment. Please make sure you go to R and you actually make sure the command you typed in will work. If you type in a command that doesn't work, then I'm going to be aware that you are not practicing to the full extent. So please make sure you try that. It's going to make your life so much easier as you move forward with R.